Greetings, children. Welcome back. So, today we're talking about factoring. So we're in a new chapter, and factoring is when we take something that's been multiplied and we break it into parts. That when we multiply those back together, you would get the original expression. So let's take a look at what that means. If you have a number like let's say 8. We can break it into factors. 8 is 2 times 4. So 2 and 4 are factors of 8. You may recall working on stuff like this in elementary and pre-algebra, where it would give you two numbers. Say, for example, it would give you 24 and 18. And it would say, what's the greatest common factor between 24 and 18? So you could list all the different factors for 24, like 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then for 18, you could do the same. 1 and 18, 2 and 9, 3 and 6. Then you see which of these are in common. So 2's in common, 3's are in common, 6's are in common, and that's it. So which is the greatest one of those that they have in common? 6. So that's kind of what we're working with here, is we're breaking stuff into factors. It's a little bit different than this, but the greatest common factor does come into play. We could say something like this. So here's an example of a problem that we might see later. 24x plus 18y. And we want to factor out the greatest common factor between these two. Well, that would be 6. And we'd be left with 4x plus 3y. So you can see we get this thing that's multiplied. We have 6 times this group. So factoring is the opposite of what we were working on last chapter, which was multiplying polynomials or monomials and polynomials, things like that. So you can see this is the reverse of the distributive property. The distributive property starts with 6 times 4x plus 3y, and you end up with 24x plus 18y. So we're going backwards from the distributive property, and we're saying, if we start with this, can we get back to this? And to do that, we use the greatest common factor. So let's look at a few more examples. First, let's talk about if we have something like, let's say 21 x cubed y squared. So what different things multiply together to give us this? Well, just as you can see, it's 21 times x cubed times y squared. So that's one way we can think of it, that 21 is one of the things that's multiplied here, x cubed, y squared. But now let's think about it. 21 is 3 times 7. These are what we call the prime factors. X cubed is x times x times x. Y squared is y times y. So we have 2 factors of y, 3 factors of x, and then a factor of 3 and a factor of 7. So we could split these into different parts and say that this is actually 3x squared times 7xy squared. So you could say that 3x squared is a factor of this as well, and that 7y or xy squared is a factor. So we can break this apart just like we did the numbers of last time when we had 24 and 18. 18, we said, well, it could be 1 times 18, or it could be 2 times 9, or it could be 3 times 6. So these are different groups or sets of factors. Now, we wouldn't use all of those factors at the same time. Here we wrote down the prime factors, 3 and 7, but 21 is also a factor. So what we're trying to do is see what factors does a group of numbers have in common? So let's take a look. Let's use that example, 21 x cubed y squared. And then let's say we had another term plus 7xy cubed. Now, you can see 7 and 21 both have a common factor of 7. You could divide both of them by 7 and you still get a whole number. Divide 21 by 7, we get 3. Divide 7 by 7, you get 1. Alright, now let's see. Here there's 3 x's, x times x times x. Here there's only 1. So they have a common factor of x. Here there's y squared, here there's y cubed. So that means there's actually 2 y's that they share. And then we're going to divide each of these by this group. So if it helps, write it down. 21 x cubed y squared over 7x y squared. These cancel. One of these cancels. This cancels. We get 3. So we're left with 3x squared. There shouldn't be anything left on the bottom when you're dividing. You don't have to do the division step, but if you're getting stuck, try that. And then here, divide this by this, and we're just left with 1, because we're dividing by 7. The x's cancel as well. Y cubed, dividing by y squared, so we're just left with 1y, or just y. Now, you can always do a quick check in your head to make sure that you factored correctly. This is called factoring out a common monomial factor. So 7 times 3 is 21, x times x squared is x cubed, and then times y squared gives us 21x cubed y squared. 7 times 1 is 7, x times this just gives us x, y squared times y is y cubed. Alright, so you can see this is kind of the opposite of the distributive property, and you can use the distributive property to check and make sure you got it correct. Let's try another one. Let's say we had 18 x to the fourth y squared z plus 33 x squared y squared z squared minus 12, and then let's say it's x to the third y to the fourth z cubed. Okay, so there's our example. Now let's see what they have in common. First we're going to look at the numbers, and this is stuff that you did, like I said, all through elementary, finding the greatest common factor between a group of numbers. So here, our greatest number that we could divide by would be 3, because this is 3 times 6, this is 3 times 11, this is 3 times 4. So 3. Now let's look at the x's. What is the least amount that each one of these has? Well, here this one has 4, 2, and 3. So 2. So x squared. What about the y's? Well, this one has 2, 2. This one has 4. So we could take out y squared, because they all have at least a y squared, which is 2 factors of y. And then how about z? This one has z, z squared, z cubed. So we can take out a z. Now, when we divide each of these, let's see what's left. This divided gives us 6. This divided gives us x squared. This divided cancels. This divided cancels. So we're left with 6x squared. Now, 33 divided by 3 is 11. X squared divided by x squared cancels. Y squared divided by y squared cancels. Z squared divided by z is z. And then the last one, we have this minus sign. Don't let that scare you. It's just going to be minus 4. And then we're dividing by x squared, so we get x. Dividing by y squared, so we get y squared. Because there was 4, we took 2 of them that we canceled. And then z cubed divided by z is z squared. So now we have this factored. We factored out our common monomial factor. So we're left with 3x squared y squared z times the polynomial 6x squared plus 11z minus 4xy squared z squared. So you can see the process itself is pretty straightforward. You're trying to find the most that you can take out of all of them, and then you write that number here, this monomial, and then you divide each one by that monomial, just like we were doing in the last section of the last chapter, dividing by a monomial. You write the quotient, what you divided to get, over here, so you get each of those terms over there. Let's look at a couple more examples that are a little easier, just so you can see that most of these are going to be more straightforward. Let's say we had 6x squared plus 15xy. Well, here you could factor out a 3x. We're left with 2x plus 5y. So there's one for you. If you multiply to check, you get 6x squared, 15y, xy. All right. What if we had 10 x to the 5th y squared minus 45 x cubed y? Well, you could factor out a 5, and you could factor out x cubed and y. So we'd end up with 2 x squared y minus 9, and the x squareds cancel and the y's cancel. So it's just 2x squared y minus 9. Okay, just a couple more quick examples so that you can see some of this again in action. So let's say we had 2x minus 24. You can factor out a 2, you get x minus 12. Okay, what about if we had 51a minus 3? Here you could factor out a 3, so you get 17a minus 1. Notice the 3 didn't go away because we factored it out. We have to be able to multiply by this to get back to this. So if you factor out the whole thing, in this case 3, you still end up with a 1 over here. Let's look at another example where that happens. Let's say we had this one. 2x minus 4x squared. 2x minus 4x squared. We can factor out 2x, and we're left with, well, 2x divided by 2x is 1. So we'd have 1 minus 2x, because when we divide 2 by 2 here, we get 2. Divide x squared by x, you get x. So make sure that you don't leave off that 1. It's very important. All right, so there's some examples, both easy and difficult, that you can take a look back at if you need to. We're factoring out common monomial factors. Hope you have a great day.